Hello everyone. I hope everyone is very good, very fine. Good evening. So again we are going with the second or next session of the rapid revision series. That is for the next chapter, that is chemical kinetics. What is chemical kinetics? Let's start with that question only. Chemical kinetics. In the chemical kinetics, what do we study? First of all, just like think this chemical kinetics, the name itself suggests that we are going to study about kinetics. Kinetics, when kinetics comes into the mind, when something moves. Okay. In chemistry, where something movement is taking place, in chemistry, the movement takes place when there is a reaction is going yes or no, for sure. So if there is a reaction going on from reactant to product, so we are moving from the reactant to product. So this is going to be, here we are going to talk about the kinetics. But you will say, sir, in the reaction so we study about many things. Even we have studied about the energy changes we have studied in thermodynamics. What is special about kinetics? So basically kinetics deals with that how fast a reaction is going on. Is the reaction very fast or very slow, or is it of the moderate? Okay, so this is something that we are going to deal in this chapter, that is chemical kinetics. चलो तो शुरू करते हैं without wasting any time. So basically what are the things that this chemical kinetics tells us about? One, the rate of any reaction. Second thing, what is the mechanism of any reaction? I hope you study in organic reaction that what is the mechanism of reaction. All these things we study here only. Next we can say that what or how fast or how slow a reaction is going on, or what will be the effect of catalyst and these things on any reaction. Okay, and temperature. So now chemical kinetics. What is chemical kinetics? Chemical kinetics, we have already studied about it, the branch of chemistry which deals with the rate of chemical reaction and the factors which influence the rate of reaction and the mechanism by which any reaction proceeds. Okay, so these are the things that we are going to study in this chemical kinetics chapter. Now the next question, that is the most important point. Basically again and again we are telling about rate of reaction. Do we have anything in our day-to-day life that we can relate this rate of reaction with? Yes, we can relate this rate of reaction with velocity. What is velocity? The distance divided by time. You can say the covered distance by the waste, whatever the used time or change in time is there, that is velocity. Yes or no? Similarly, in any reaction, what is the distance we are covering? We are covering from the reactant to product. So basically this is the distance, and what is the time? The time taken to complete the reaction. That will be the, I hope you understand it, how you can say what is the rate of reaction. So change in concentration is something, that is how we can say that at the place of distance we can keep concentration, and for the time we can say just use time. So we have an analogy for reaction, that is velocity. Here velocity used to be change distance, and change in distance by change in time. But rate of reaction will be change in concentration by change in time. Concentration can be of reactant as well as for product. Okay, so this is something that we are going to study about. So rate of reaction equals to change in concentration of a reactant or product by time taken for the change. Now everyone we know that. How can we say that change in concentration of reactant? We can say concentration of the reactant, we can say later on at time t2 or t2 minus time t1 divided by t2 minus t1. This is something that we can say, or we can also say it as p2 minus p1 divided by t2 minus t1. What is this? R2 is nothing but it is the rate of reaction, or you can say concentration of the reactant at any time t2, or it is R1 is what? It is the concentration of reactant at time t1. What is p2? It is the concentration of product at time t2, and it is what? It is the concentration of product at time t1. I hope it is very understandable thing. But we know that in any reaction the reactant is consumed, so its concentration will be decreasing. So in that case what we can say, R2 will be less, R1 will be more, because initially it will be more and finally it will be less. So in such case R2 minus R1 will be positive or negative. I hope you can see that this is going to be a negative value, while P2 minus P1, because we know that products are formed in any reaction, so with time it will be increasing, so P2 will be more than P1, so therefore this is going to be a positive value. So please keep in mind, if you are using R equals to change in concentration of reactant divided by change in time, so here use negative sign, while if you are using product. So delta P by delta T. Use positive sign. Is this okay or not? क्या यहाँ तक बात समझ में आ रही है? Very good. Next, units of the rate of reaction. What is the unit of rate of reaction? I hope you can see that. Change in concentration. So concentration will be in the numerator. Time is in the denominator. So basically unit comes out to be unit in terms of concentration. In terms of concentration. Concentration for solution as well as and gases, for both of them. No issues. We can use, and that will be what? Mole per liter. Mole per liter per second, because time is what? Per second, or you can say per time. Per time. It can also be written as per minute or per second. Okay. Now, what about this? If it is in pressure, unit in terms of pressure. And pressure किसके लिए use होता है? Pressure is used for gases. Okay. What will be the unit? I hope you can see that pressure has the unit ATM. Generally we use ATM. ATM per time. Or we can also say ATM के जगह पे we can use bar, or we can also use torque. So I hope these things are very clear and very understandable things. So these are the units of, always remember, units of rate of reaction. Next, how do we write this rate? कैसे represent करते हैं इस rate को? Now this was just a, you can say that this was just basic representation. It is not the complete, or you can say final representation. Final representation of rate will be this. Let's see. If there is instantaneous, at any point of time, what is the rate of change of any reactant or any product will be called instantaneous rate of reaction. How do we find out? I think basic mathematics, everyone, you know that at any point of time, if you just differentiate that function or that concentration with respect to time, at any point of time, whatever is the slope, that is dC by dt, whatever, change in concentration by change in time, that is very small concentration change divided by very small time change, you get that slope, and that slope is only telling you about that, that is rate, that is nothing but instantaneous rate. So how you say it? Consider A is nothing but stoichiometric coefficient, BB giving CC DD. Okay, so in such case, whatever is the stoichiometric coefficient, you just divide it. You just divide by that. So 1 by A with the negative sign. Why? Because it is a reactant. It is a reactant. And for reactant, I told you that what do we use? Negative. Negative for reactants. Negative for reactants. While positive for products. I hope you understand. So minus of 1 by A in ddt of A. Minus of 1 by B into ddt of B. Not a big deal. dB by dt. Yes. Equals to 1 by C dC by dt. Equals to 1 by D dd of by dt. Not a big deal, easy. Now H2 plus I2 giving 2HI. For this reaction, can you see that what is that? 1 mole giving 2 moles. So what we can say? Minus of 1 by 1, that dH2 by dt, equals to minus of di2 by dt. For this, what will be there? 1 by 2 dH by dt. Any issue? No issue. I hope so. It is very easy to understand. ठीक है, बच्चों वाला चीज. Now, but here again one more thing that is due, that is rate of reaction with respect to any reactant and product. Let's see. Consider if they will, how do they write the question? Such kind of question. They just write for reactant, what is there? A reactant dissociates, or you can say that what we can say disappears. So rate of disappearance, they will write rate of disappearance. Acha, take one of the reactant from here. Consider I am taking A, disappearance of A. What will be there? It will be minus of dA by dt. Now you say, where is 1 by A? 1 by A. Here stoichiometric coefficient is not used. Please keep in mind what you will say. And so rate of disappearance of B will be minus of D concentration of B by dt. Chalo bhai, what about the product? With time the product appears, or you can say it will be formed. So in such case, what will say? Rate of appearance. Rate of appearance of, take one of the products. Product is C. What will be that? Plus of dC by dt. And what about the ROA, rate of appearance of D? It will be d by dt. Not a big deal. So here, what we just have to keep in mind, if it is asking in the term of reactant or product, we do not have to take any of the stoichiometric coefficient. That's it. Okay, चलो आओ आगे बढ़ेंगे. Now types of reaction, there are three types of reaction. One is very fast, that is ionic reactions, generally like neutralization reaction, you know, acid base reaction, these kind of reactions are there. Is that okay? Next, very slow reactions. What is, or very slow reaction are those reactions that, you know, you just keep on waiting for that, what is changing, is there some change in concentration of reactant product, but you will not see any change in whatever is the, you know, you measurable time like seconds, minute or hours. You will not see any change in such kind of reactions. Like, what is the example for that? Let's say rusting of iron. Whatever is the rusting takes place, it takes a lot of time, right? So this is a very slow reaction. So there the rate of reaction has no meaning itself, right? Because the time is very, very large. So I'll always remember, we do not do this rate study for these two types, that is instantaneous or very fast or very slow. We do the kinetic study only for moderate rates. Matlab, it is neither very fast that you cannot see the reaction happening, or neither so slow that you cannot even measure the time, right? So in such case, what we can say here, kinetic study is done. Kinetic study is done in these kind of reaction having moderate rates. What are these? Generally they are covalent in nature. चलो आओ भाई बातें करते हैं. In the reaction, this, okay, there, this is the reaction, the rate of appearance of bromine. See, rate of appearance it has given, right? Rate of appearance of bromine. What is the rate of appearance bromine? Can I write it? Yes, just help me with that. Rate of appearance of Br2 will be equal to, how will you say, dt of Br2. This is the rate of appearance of bromine. Now it is related to disappearance of bromide ion. Okay, so rate of disappearance of bromide ion will be equal to minus, why? Because it is disappearance, negative of d of bromide ion divided by dt. Okay, now this is something, now we have to find out their relationship. How do you find out the relationship? I hope you all remember rate of reaction. What is the rate of reaction we have written? Rate of reaction mein both of them were being used, but with their stoichiometric coefficients. Chalo, use the stoichiometric coefficient for bromine. What is the stoichiometric coefficient? Br2 has 3. So 1 by 3 dt dBr2 by dt equals to, what about that bromide? Bromide has the stoichiometric coefficient 1 by 5. Chalo bhai use kar do. 1 by 5 d bromide by d time. Can we see? So I hope you all can see that this is nothing but, kya mujhe koi help karega? What is this? It is nothing but rate of appearance of bromine. It is the rate of appearance of bromine. While with the negative sign, it is the, with the negative sign. I think I have not used that negative sign. Let me first of all. What is this? With the negative sign, dBr minus by dt is nothing but, it is what? Rate of disappearance of bromide. I hope you can see that. Just see that where is the correct option. You can just match it. Negative sign should be there. Wherever without negative sign, it is wrong. Okay. Br2 has the stoichiometric coefficient 1 by 5. 1 by 5. Okay, 5 by 3. Bromide has 1 by 3. 1 by 3. 1 by 3. No. Option D is the correct option. I can see it very easily. Can you see? Br2 send this 3 this side. So minus of 3 by 5. Minus of 3 by 5. D of bromide by D of time. So option D is the correct option. Just see the option and get the answer. Next. For the reaction N2O5 converting into 2NO2 and half O2, the value of the rate of disappearance of N2O5 is given as this much. Okay. So what is that? dt of N2O5 equals to how much? Given 6.25 into 10 to the power minus 3 mole per liter ko I can say molar per second. So this is what, this is something that is given. What it is asking for? The rate of formation of NO2 and O2. Okay, so we are trying to find out both of them. Okay, so again you will write the rate law expression. What is that? Rate of, it is also called differential rate law expression. Why? Because we are using differential notations. Yes or no? Now in such case what we can say? It will be 1 by 2 with that negative sign. So 1 by 2 of d of NO2 equals to, what we can say? This is nothing but rate of appearance of NO2 equals to, what we can say? Half. 1 by half equals to 2 times of rate of appearance of O2. Because 1 by half becomes 2. it is equals to rate. अच्छा इसको अब जरा देखो, इसके फॉर्म में लिख करके देखो, it is nothing but rate equals to, अरे rate equals to 1 by 1. 1 by 1 is what? 1 equals to rate of disappearance of N2O5, and rate of disappearance of N2O5 is given how much? 6.25 into 10 to the power minus 3. I hope you can see rate of appearance will be equal to 2 times of 6.25. 2 times of 6.25 will become 12.5 into 10 to the power minus 3. 12.5 into 20, okay, but it is given in 10 to the power minus 2 form. So 1.25 into this. Okay, only these two options is possible, either this or that. Okay, let's talk about oxygen. It will be half of 6.25. Half of 6.25 will be, send it this side. If you equate both of them, 6.25 divided by 2 is 3.125. 3.125 into 10 to the power minus 3. 3.125 into 10 to the power minus 3. But it is not the correct option. So option B is the correct one. Not a big deal. You just have to equate with the help of rate law expression and get the answer. Okay, next. Average rate of reaction. What is average rate of reaction? When there is a bigger change in concentration by bigger change in time, it will be average rate of reaction. So if you are, let's say, if it is defined as a rate of change of concentration of any one of the reactants and product during a time interval, when there is a bigger time interval. While if you talk about the instantaneous, it is defined as the rate change of the concentration of any one of the reactant or product at a particular moment of time. So at any point of time, whatever is the change in, or you can say rate of the reaction, will be called the instantaneous rate of reaction. What is the graphical analysis? The graphical analysis is very important. Let's see. Let's say that we are changing from T2 to T1. Here the concentration is changing from A1 to A2. So here A2, A1 minus A2, or you can say A2 minus A1 divided by T2 minus T1. So it will be average rate, R average. Okay, so it is for, you can see that it is for reactant. Why? Because it is decreasing with time, it is decreasing, so it is for concentration of reactant, while with time it is increasing, so it is for product. So can you see that at time T1 is A1, at time T2 is A2, because A2 is more than A1. Here it was A2 was less than A1, so here it will be a negative thing. But here when you talk about R instantaneous, it will be equals to what? R average here will be how much? A2 minus A1 divided by T2 minus T1. But it is what? It is a positive value. It is what? Positive value. Not a big deal. You can just see that. Okay? Not to think much more about that. Next, rate law expression. What is rate law expression? what is rate law? Now, the expression that correlates the rate of reaction with concentration of the reactants is known as rate expression. Please remember that I have not told product. It is only telling about the concentration of reactant. So, rate with concentration of the reactant, not with the product. Okay. So, if the rate is written like K, A to the power A and B to the power B, in such case, what we will say? This is the rate law expression. It is what? Rate law expression. One more thing. Consider this reaction was something like that. PA plus QB giving product. So there is no relation of this stoichiometric coefficient with the power that is raising here. So power, whatever the power is being raised here, it has no relationship whatever is the stoichiometric coefficient. These P and Q are stoichiometric coefficient. They are stoichiometric coefficients. They may or may not be, that may or may not be equal to order of reaction. What is this order? This is order A. A and B are what? Order of reaction. A is order for A, order with respect to L, while B is order with respect to B. So K is the rate constant and A and B are the order with respect to reactants, which may or may not be same as the stoichiometric coefficients of the reacting species in a balanced chemical equation. A very important point. And what is this K? K is nothing but it is the rate, you can say rate constant, or it is also known as specific rate of reaction. Specific rate of reaction or rate constant, anything can be given. Now rate constant or specific reaction rate, what is that? Here we can see that rate equals to K, A to the power P, A to the B power. You can see that here we have used A, B, C, but power is raising P, Q, R. So what we can say that A, B, C has nothing to do with this P, Q, R. So what do we do? What do we say? When we add all the whatever the powers we have raised, if you add all the powers, we get the order of whole reaction, not with respect to any reactant. So if you add P plus Q plus R, we get N. N is the order of reaction, then K will be equal to, what will be the unit of K? Please remember, it is very, very, very important. Unit of K equals to mole per liter power 1 minus n per time. In terms of concentration, so what we can say? We can say it is mole power 1 minus n, liter power n minus 1 per time. Time may be minute or second, anything. And if you are using pressure, unit of K, in terms of pressure, it will be ATM. ATM power 1 minus m per time. This time can be second or anything. Okay. And dikkat, no dikkat. Characteristics of rate constant. What this depends on, what this does not depend on. Higher the value of K, greater the rate of reaction. So the more the K will be there, the more the rate of reaction will be there. At a particular reaction has a definite value of K at a particular temperature. If you do not change the temperature, K is not going to change. Okay. Next, the value of rate constant increases with temperature, and K is directly proportional to temperature, irrespective of delta H. Means delta H, even if it is positive or negative, means even if it is endothermic or it is exothermic. So whether it is endothermic or exothermic doesn't matter. If you increase the temperature, the K will always increase, means the rate of reaction will also increase. Yes, but the whatever is amount of product that is being formed, that is a thermodynamic property, that is not the kinetic property. That depends on that. That depends on temperature. If you increase the temperature for exothermic reaction, the products will be less, and for endothermic reaction, the products will be more. But the speed in both the reactions will be raised or increased if you increase the temperature. Is it okay? Why? Because those reactants get more and more energy, and more collision takes place. So more and more collision will lead to higher rate of reaction. But I'm not telling about the more amount of product formation. Product formation is something that depends on Gibbs free energy change, that is delta G, and that will completely a thermodynamic property, while here K is nothing but it is a kinetic property. Okay, whatever I told you, I hope it is very clear to you. Now, it does not depends upon the initial concentration of reactant. Whatever the reactant or product, doesn't matter. It will not depend on it. Now, its unit depends on the overall order of reaction, as we have already seen that, because it is in the unit, it is coming N. N is nothing but overall order of reaction. Any dikkat? I hope so. You all can see. Now we will solve some questions. Of course, there are many things to say, but still we cannot cover all these things here only. So let's see few important type of question. The rate of reaction for this reaction is given by, okay, this the value of the rate constant can be increased by. Okay, so how the value of rate constant can be increased? By increasing concentration? No, concentration by it does not depend. Increasing the temperature? Yes, only this one. Okay, chaliye. Order of reaction. What is order of reaction? The power to which concentration terms of the particular reaction in the, okay, whatever is the power that is raised, that is called order with respect to that reactant. Okay, so what this order says, this order tells you about the how sensitive a rate of reaction is with respect to any reactant. So if I change a concentration of any reactant and the rate of reaction change by a very large quantity, so you will say that it is very sensitive, so its order will be high. It may be positive, it may be negative, that's a different thing. But if the change is high, so we'll say that order of reaction is high. Now, if you change the concentration, but the change in reaction rate is very less, so we'll say that order of reaction is smaller. So this may be positive, this may be negative. Okay, that's a different thing. Now, what will happen if you change the concentration of the reactant, but the rate of reaction does not change at all? What will happen? Means it does not depend on the concentration of that reactant. So what we'll say that the order with respect to that particular reactant is 0. Okay, I hope so. It is all very clear. And what is the overall order of reaction? I hope you can see that P plus Q plus R. Okay. Now here, of course, we have already studied about it, that for 0 order reaction, first and second order reaction. Next, what is molecularity? There are few things that I would like to talk about, that characteristics of order. Characteristics of order question may come from here. Please keep in mind whatever I am writing here. First is that order is experimental value. Value. We cannot just see a reaction and we can say no, we can never. Next thing, that order can hold any value. Order can be positive, negative, 0, fractional, anything. Any value can be hold. Next, what about this? Now order is this. Now for a single step, or we also call it simple, or we also call it elementary reaction, the order with respect to any reactant becomes equal to stoichiometric coefficient of that reactant. So we will only say it or that stoichiometric coefficients become equal to order of reaction when it is a single step reaction. It is not a complex reaction. Okay. So fourth, for complex reaction, it has to found by the mechanism that is experimentally. So these things are there that you have to always keep in mind. Okay, now this is about the order. What about the next thing, that is molecularity? Always remember, molecularity is what? It also looks like order in many sense, but it is not. What is that? Molecularity talks about, let's say if there is a reaction, you have to consider something. If there is a reaction going on, molecularity says that for taking place of any reaction, reactants need to collide with each other. At any point of time, whatever the number of reactants are colliding together at any point of time to give the product, that will be equal to the molecularity of the reaction. So at any point of time, the number of simultaneously colliding reactants at any single point of time will be called molecularity to give the product. Of course, to give the product. Like example, I will tell you. I'm directly giving you example because definition is something that I've already told you. Example like, let's say 2HI converting into H2 plus I2. What is, how many number of moles of HI is there? 2. Not moles, but consider it in the molecular form, not in the molar form. Means two molecules of HI are giving H2 plus I2. So therefore, molecularity will be equal to 2. Next example, check karo. Ammonium nitrite. What we can say that here it is converting into N2 plus H2O. What we can say, how many moles of ammonium nitrite is there? 1 mole. So what we can say, here molecularity will be equal to 1. So now keep few things in mind. Characteristics. What are the characteristics? First, it is, what is that? It can not be negative, 0, fractional. It cannot be negative, 0 or fractional. So it has to be a positive whole number. Second, what we can say, that it maximum possible value of molecularity is equal to 3. It cannot exceed 3. It cannot be more than 3. Okay, these are the main points that we have to keep in mind. Third thing, that it is not defined by, or you can say directly say, it is defined only for one step reaction. One step reaction को ही हम लोग क्या कहते हैं? Elementary or simple reaction. It is not defined for complex reaction. Zero order reactions are complex reaction. So what we can say, that molecularity is not defined for zero order reaction also. क्या ये बात समझ आ रही है? Okay. चलो आगे बढ़ते हैं. For a reaction A and B, the order with respect to A is 2 and order with respect to B is 3. The concentration of both A and B are doubled. Then rate will increase by, first of all, write the rate law expression. R equals to K. A to the power, order with respect to A is what? 2. Order with respect to B is what? 3. So let's say it is R1. What will be R2? R2 will be equal to K. तो किसी चीज पे डिपेंड नहीं करे, K will be same only. What you have done? You have made both of the A and B twice. So 2B by cube. It will be what? 2 square is 4. 2 cube is 8. 4 8s are 32. K A square B cube. Now can we see that it is nothing but it is R1. It is what? R2. So R2 equals to 32 times of R1. So do we need to do that again and again? No, never, never, ever. ये तो बहुत लंबा time हो गया. Now for solving, question solving, what you have to do? Always think in that, very smart. How much time this A is becoming? It is becoming twice. So A, and what is the order with respect to A? Order with respect to A is 2. So 2 square multiplied by, what is the order with respect to B? B is cube. So 2 cube. It is what? 4. It is what? 8. 4 8s are 32. Directly say how many times? 32 times. Okay. So be smart. Do not go like that. Okay. Next. In a reaction A plus B to product, rate is doubled when the concentration of B is doubled. What we can say? If the B is doubled, so R is directly proportional to, consider B to the power 2. B to the power x. Okay. Now and A to the power, consider A to the power x and B to the power, A to the power x and B to the power y. Now it is telling you, when our rate is becoming double, whatever is rate becoming, just write this number. Do not write the R or anything. No. What that is becoming? The rate is doubled means 2 equals to. Just equate that. And when B is doubled, directly write that at the place of B, just write the number. How many times B has become? 2 times. So 2 to the power y. When 2 to the power y equals to 2, then when y will be equal to 1. Means what we can say? This y is equals to 1. So rate with respect to B is what? 1. Just what I'm saying you, not just remember and always put that. It is the shortcut. Whatever the rate has become 2 times. Okay. B has become how many times? We have seen that B has become 2 times. B has become 2 times. But of course we have to raise the y, whatever is the order of reaction. Now equate both of them. 2 equals to 2 to the power y. When y will be equal to 1. Only possible then. Next, talk about A. and rate increased by 8 factor. Okay. Rate increased by 8 factor when the concentration of both the reactant A and B are doubled. Okay. When A is also being doubled means 2 to the power x, and B is also being doubled when 2 to the power y की value तो पता है हमें कितनी है 2. So what we can say? Cancel करो. It is 4. So 4 equals to 2 to the power x. So what we can say? It is nothing but it is 2 to the power 2. So it is only possible when x will be equal to 2. X equals to 2 means the rate with respect to A is what? 2. So overall order of, so what we can say? Which is the correct option? A to B1, A to B1, A to B1. That option D is the correct option. Okay, not a big deal. Next. Which one of the following statements for the order of reaction is incorrect? Order can be determined only experimentally. Yes. So it is true. Next, order is not influenced by stoichiometric coefficient of the reactants. Okay, stoichiometric coefficient? Yes, for sure it is also correct. Next, order of reaction is some power of the concentration of the terms of the reactant to express the rate. Yes, order of the reaction is always whole number. No, it is wrong. So that's why it is correct option. Next, during the kinetic study of the reaction 2A plus B to C plus D, where the results were obtained based on the above data, which of the following is correct? Okay, this is the data given. Such kind of question is given where the experimentations will be given and change in concentration of the reactants will be given and rate change will be given. कैसे करते हैं? Please follow the same steps. Do not change it. Always see that only you have to compare the data. And which data to compare? Only compare those data where the change in concentration is only in reactant, one of the reactants is taking place. Okay, here what is happening? Here both the reactant is becoming. Here it is becoming 2 times. Here it is becoming 3 times. No, do not compare 1 and 2. Think about 1 and 3. If you compare 1 to 3, changing. 1 to 4, changing. No, do not compare it. Just compare, try to compare 2 and 3. 3 to 3, no change. Yes, it is going good. 2 to 4. Of course, we can see that only one change is there. If one change is there, how many times it is becoming? 2 times. Consider it is R equals to K, A to the power X and B to the power Y. Now, how to find out this A to the power X and B to the power Y? Now, I'm telling you same thing. You have to follow. What is happening? This we have made it 2 times. And how much of the rate has changed? Made the 10 to the power minus 2 same. 10 to the power minus 2, then it will become 28.8. 28.8. Okay. So it is becoming how many times? Can you see? It is becoming 4 times. What did I say? Backside, write the rate as it is. Rate equals to, what is changing? B or A? B. How many times it is becoming? 2. 2 to the power, raise the power, whatever is the order. 2 to the power Y. When it is possible? When the Y is equals to 2. When Y is equals to 2. So rate order with respect to B is what? 2. Simple. Now, see where only A is changing. Can you see that 1 and 4? 1 and 4. It is becoming 4 times. Well, it is same. It is same. It's good thing. This time only A is changing. How many times the A is becoming? A is becoming 4 times. A is becoming 4 times. And what is the rate becoming? Rate is becoming, chalo, make it in the same 10 to the power minus 3. It will become 24.0. How many times it is becoming? 6 to 24 means it is becoming 4 times. When it is becoming 4 times, it is also becoming 4 times. So what we can say? Same thing again. You repeat. Rate is how much? How many times? 4 times. A is becoming how many times? 4 times. To the power what? X. When it is possible? When x equals to 1. So put x equals to 1. So what will be the rate law expression? A b power 2. A b power 2. A b power. Option D is the correct option. I think it is very easy to understand and do such kind of question. The rate of reaction between two reactants A and B decreases by a factor of 4. Okay. Rate is becoming 1 by 4. I'm directly writing. I'm not writing R by 4 or anything because I told you how. Why? And the reactant is when the reactant concentration of B becomes, okay, 2 times. Then order of with respect to B. Okay, it is only asking for B. It is not asking for A. So how we can consider that R is directly proportional to B to the power X. Chalo bhai dekhte hain. So how much times the B is becoming? B is becoming 2 times. 2 to the power X. Whatever is the order, we have to raise that. What will be? It will become. It is nothing but 2 to the power minus 2. 1 by 4. It is 2 square. Upar gaya. 2 to the power minus 2. 2 to the power X. So X will be equal to minus 2. So option is option B. Okay. Not a big deal. Next question is. Now we are on the very important. In fact, you can say that most important type of question, that is integrated rate law expression. You have to remember it first of all. What is general order integrated rate law for nth order reaction? What is that? Let me show you. Consider a reaction A converting into product. Okay. If it is a reaction, and what is the order of reaction? Consider order of reaction is nth order reaction. So that's why I have considered. Consider at time t equals to 0, its concentration is C0. At time t equals to its concentration is what? Ct. So in such case, what will happen? How do you write that? We have to write the rate law expression. Rate law expression. How do you write rate law expression? We know that R equals to minus of dA by dt. It will be equal to what? Rate equals to yes or no? Differential rate law. Now equate it with that. What do we see? K into A to the power. Whatever is the reactant, raised to the power their order. What is the order? Nth order. Okay. Any doubt? No doubt. We can equate both of them. Now from equating, what we can say? Minus of dA by A to the power n. It will become A to the power minus n equals to K dt. Now what we can do? We can just integrate it. Integrate the concentration. From which concentration we have started? C0. From to which concentration we are going? Ct. What is the time it is using? From time t equals to 0 to time t equals to t. And what will be the final answer? I'm writing the final answer. So after doing all these calculation of integration, we get the final answer comes as, you can see that, C0 to the power 1 minus n minus Ct power 1 minus n divided by 1 minus n equals to Kt. A very important general formula. It is what? General formula. It is general formula. Now, if it is a general formula, just tell me few things here. Can we put n equals to 1? No. If you put n equals to 1, 1 minus 1 will be 0. And anything divided by 0, it will be undefined. So here n should not be equal to 1. Means not for first order reaction. It is only for, so n should not be equal to 1. It is valid for any other rate of, you can say, order of reaction, but not for first order reaction. Is it okay or not? Now, chalo aage badhenge towards the particular order of reaction. First is zero order reaction. For zero order reaction, n equals to 0. N equals to 0. How can we say the rate law expression? R equals to, consider there is a reaction A to product. So R will be equal to K, A to the power 0. A to the power 0 because it is zero order reaction. So what we can say? R equals to K. Array, but K is a constant. K is a constant. So therefore, rate here will be, rate of reaction here will be, rate of reaction for zero order reaction is going to be a constant. A very important point that comes out from here. Okay, we are going to write it down later on. Now, for Zero order reaction, we have seen that. Second thing, what will be the integrated rate law expression? Integrated rate law expression. Now, just use it with the whatever is the generalized form, C naught to the power 1 minus 0 minus Ct power 1 minus 0, divided by 1 minus 0 equals to Kt. From where it is coming? It is coming from the general formula. General, yes or no? From the general integrated rate law expression. So what will come later on? The final formula that comes out to be here, Ct equals to C naught minus of Kt. So it is IRL for zero order reaction. Why do we use it? We use for relating the Ct with T, means concentration of the reactant at any given point of time for zero order reaction. Okay, can we see? Chalo, तो ये बहुत important point रहा. Now next point that is asked here is T half, that is half lifetime, half life time, that is also known as T 50%. It is the time when 50% of the reactant is consumed. When the 50% of reactant is consumed, if the 50% of reactant is consumed, later on, if you solve it, what will happen? At T half, what will happen? Ct will be equal to C naught divided by 2. If half is removed, so what will happen? Half will be remaining. So T is what? T is equal to T half. Just equate both of them. What you will get? You will get C naught by 2 equals to K T half. Kt half. So T half will be equal to C naught by 2K. As a rule, always remember what we have seen, that T half for any order reaction is directly proportional to C naught to the power 1 minus N. Here N is what? N is the order of reaction. It's a very important point. यहाँ से question कई बार solve हो जाएंगे directly. T half is directly proportional to C to the power C naught to the power 1 minus N. If zero order reaction, so 1 minus 0 is 1. So T half is directly proportional to C naught in zero order reaction. For first order reaction, 1 minus 1 is 0. So C naught to the power 0 is, means T half is independent of initial concentration for first order reaction. If it is equal to 2, so 1 minus 2 is minus 1. So T half will be inversely proportional to C naught, means initial concentration के inverse relation कब होगा? जबकि T half equals to when order of reaction is second order reaction. Okay, now these things you have to keep in mind. What else you have to keep in mind? For always remember, zero order reaction reaches to completion. To completion means it completes. Second thing, rate of reaction is always constant for zero order reaction. For a zero order reaction, what is constant? Rate of reaction is constant. Now let's talk about the graphs. Important graphs of zero order reaction. The first type of reaction is Ct versus time. Ct versus time, how it will be? What is the formula? Ct equals to C naught minus Kt. Can we see? If you say it y and t is the x, it is what? M with the negative sign, it is what? C. So what we can see that it will be something looking like y equals to mx plus c. Here m is negative or positive? Negative. So means downward slope, not the upward slope. What is C naught? C positive or negative? Positive. So what is that? It is concentration of reactant. This is what? Time. इसको हम लोग बोल सकते हैं Ct. It is what? C naught. And what is the slope? Slope equals to minus of K. Is that okay? That is what we have to keep in mind. ठीक है? Any दिक्कत? No दिक्कत. चलो. Next we have to see that another. You can see that next graph is second graph. We can write rate versus time. Always remember, because rate of reaction for zero order reaction is going to be rate versus time, always constant. So it will be straight line. Either it can be rate versus concentration. Rate versus concentration. What will be there? It will also be, because we know that rate of the zero order reaction is also going to be, of course, constant. So therefore straight line. Yes. Next is going to be third type, T half versus C naught. What is the value? I hope you remember. T half for zero order reaction equals to C naught by 2K. So how can you make the graph? You can see that y equals to mx plus mx. It is y, and it is what? Can you see? X. M is what? 1 by 2K. So what we can say? It is something like that. It is what? C naught. It is what? T half. So what we can say? Sorry, T half is this side. Y T half in this side, and it is what? C naught. What we can say in such case, what is the slope? Slope equals to 1 by 2k. 1 by 2k. Okay. Now, this is something I hope it is very clear. Next one is example of zero order reactions. Please keep in mind and please consider whatever I'm telling you, because everything cannot be covered here. So for knowing all the example of zero order, second order, first order reaction, read NCERT and other sources if you have. Just read all of them. If the question comes, it's a rectification thing. Please, you can just go through it. Okay, next. Second order reaction. For second order reaction, use general integrated rate law expression. What is the general integrated rate law expression? What is that? C naught to the power 1 minus n minus Ct power 1 minus n divided by 1 minus n equals to Kt. And for second order reaction, what is the n value? N value will be equal to 2. So what we can say? C naught to the power minus 1 minus Ct power 1 minus 1 minus 2, or that is what? Minus of 1 divided by minus 1 equals to Kt. What we can say from here? 1 by Ct equals to 1 by C naught plus Kt. This comes out to be for second order reaction. That is integrated rate law expression for second order reaction. Very, very important. Please keep in mind. Next, we'll directly come to the next point. That is, what is the T half for the second order reaction? For T half, what we can say? T half equals to T will be equals to C naught by 2. Yes or no? For sure. I hope you understand. And T will be equals to T half. What is the integrated rate law? 1 by C naught equals 1 by Ct. That is what? C naught by 2. So this will become 1 by C naught plus K into T half. Can we send it this side? Yes. 1 by C naught equals to K T half. So T half for second order reaction comes to be 1 by C naught into K. Please keep in mind. And what I told you backside, that T half is directly proportional to C naught to the power 1 minus n. Here n equals to what? 2. 1 minus 2 is what? Minus 1. So 1 by C naught. Can we see that 1 by C naught? Yes. T half is inversely proportional to C naught. Yes or no? Perfect. So what we can say? For second order reaction, T half equals to this. Important. Please keep in mind. Chalo bhai, aage badhenge. What we can say? Next thing that is important. Does it reach to completion or not? No. Second order reaction does not reach to completion. Means it never completes. So, but still you will say that, sir, second order reaction, so we see that completion takes place. Array. Always remember, when the 99.9% of any reaction or 99.99% of any reaction is done, experimentally we consider ki reaction is completed, but in reality it will never complete. Why so? There is a, you can say mathematical, or you can say natural barrier is there. Next, let's talk about the characteristics of second order reaction. Piche hum sabne dekh liya. Now we are going directly to the graph. What is that? Graphs. Important graphs. We can say first one is going to be 1 by Ct versus time. How the 1 by Ct versus time will be looking like? I think everyone you know that 1 by Ct equals to Kt plus 1 by C naught. So is it not looking something like y equals to mx plus it is what? C. So chalo bhai, zara dekh lo bana karke. Can you not see? It is what? 1 by Ct versus time. Chalo. Y equals to mx plus c with the c value that is positive, means it is what? It will start, let's say it is 1 by C naught. Acha, m is positive or negative? M, that is slope, that is also positive. If it is positive, then going up or going down? Going up. Acha, what is this m? I hope you can see that slope will be equals to k. Any doubt? I think it is not a doubtful at all. So ye ho gaya aapka graph 1 by Ct versus time. Chalo bhai, next we are going to talk about second is rate versus concentration. What is rate versus concentration? Chलिए बताइए. For any of the second order reaction, consider A2 product. So what will be the rate law expression? R equals to K A to the power 2. So how do you say that? You will just make it something like that. Consider it is rate and it is what? Concentration. It is what? Rate, concentration. So concentration power 1, whatever is power concentration power 2. whatever is the power, you can say, and rate to the power 1, तो जहां पे रेट कम होता है और यू कैन से whatever is the power 1, वहां पर आप एक पैराबोलिक कर्व बनाओगे. हाउ पैराबोलिक कर्व, दो इट इज फॉर्म लाइक दैट, बट वी नो दैट ये नेगेटिव में नहीं जाएगा, कंसंट्रेशन कैन नॉट गो इन द नेगेटिव, तो मैथमेटिकली तो इधर से होना चाहिए पैराबोलिक कर्व, बट वी विल ओनली मेक दिस वन. But we generally see it is not asked rate versus concentration, but they ask you in the question for your, you can say, convenience, they ask for rate versus concentration square. Then what it will become? It will be something like that, rate versus concentration square. It will be just like y equals to mx, it will be y and it will be considered as x, then y equals to mx. Graph will be just like a straight line. Okay, so these two types of graph may be asked, please keep in mind. Next, third, t half versus c naught. How it is? चलो देखो, t half was equals to 1 by kc naught. Now we can say that c naught into t half equals to 1 by k. It is what? It is a constant. So can we say that it is x into y equals to constant? And xy equals to constant is nothing but rectangular hyperbola. Rectangular hyperbola. Can we see that? It is what? Consider if it is t half and it is what? C naught. So it will be something like this. Okay. But sometimes they ask you not in this form, but they ask you t half versus 1 by c naught. T half versus 1 by c naught कैसा दिखेगा? Think about it. Because t half equals to 1 by k into 1 by c naught. Is it not looking like कैसा ही दिख रहा है? y equals to m into x. Y equals to mx कैसा दिखता है? A straight line passing through origin. Straight line passing through origin means like this. What is that? It is t half and it is what? 1 by c naught. Is there any issue? I do not think so. So that is how we can solve such questions. Okay. When initial concentration of a reactant is doubled, then half life period of a zero order reaction is. क्या हमें पता है? Yes, we know that, because for zero order reaction, what happens? T half is directly proportional to C naught to the power 1. So if concentration becomes 2 times, then T half will also become 2 times. So it will also become double. Any दिक्कत? Easy है. Next, first order reaction. I hope you all know that. देखो फिर से यहाँ पर भी वही सारी चीजें, इसके integrated rate law expression. How do you do that? For that, consider a reaction A2 product. In such case, what will happen? If you just make integrated rate law expression, I'm not doing all those derivation. I'm directly writing KT equals to ln C naught by CT. C naught is what? Concentration at time t. Ct is what? Concentration at time t. Or we can also say Kt equals to 2.303 log of C naught by Ct. Please keep in mind. तो ये important है. Most of the question comes from the first order reaction. ऐसे question इसी integrated rate law expression से. From here, if it is asking for T half, what T half comes out to be? T half equals to 0.693 by K. What is K? K is nothing but it is, I hope you all know that, K is what? Rate law expression or rate law. Okay. If Tx% is asked, how do you say that what is Tx%? So it will be Tx%. Let's say it is asking for when 30% of the reaction is completed in first order reaction, then what is the time it is taking? So you will use that Tx% equals to, or you can say K into Tx% equals to, you will say ln of C naught by 100 minus Ct, or you can say 100 minus x, or you can say it will say C naught will become 100 by 100 minus x. Please keep in mind, very important. If it is Tx%, let's say 30%, so 100 by 100 minus 30, that is 100 by 70. 50%, 100 by 2. I hope you understand it. Okay, you can convert into log base 10, 2.303 log of 100 by 100 minus x, that is k t x%. Okay, now next one, what we are going to study, we are going to talk about relation of t half with important times. ये important times कौन कौन से हैं भाई? Important times, whatever I'm telling you, Directly remember it as it is. Do not question it how. We have solved all the integrated rate law expression and we got that. T 75%, T 87.5%, T 90%, T 99%, T 99.9%, T 99.99%. I hope you understand where it is going. More and more T9 will keep on coming. Here it will be equal to 2 times of T half. T 87.5 will become 3 times of T half. It will become 3.33 times of T half. What is 3.33? It is nothing but 10 by 3 T half. Please keep in mind, next T99 is how much? Just add 3.33 into it, 6.66 T half. It will be 20 by 3 T half. There we have written 10 by 3. Here it is 20 by 3. Yes or no? It is what? 9.99 T half. इसी को प्यार से क्या बोल सकते हैं? We can say it is 10 T half. अरे 10 by 10 मतलब 30 by 3 T half. Yes or no? Next, what is that? 99.999. So here what 99.99. So what it will become? Add 3.33 into it. 13.34 T half. That is nothing but that is 40 by 3 T half. I hope you all understand it. क्या ये बात पक्का समझ में आ रही है? ये याद रखना है, डायरेक्टली क्वेश्चन करने में इट विल हेल्प यू अ लॉट. नेक्स्ट, हाफ लाइफ ऑफ द फर्स्ट ऑर्डर रिएक्शन. हाफ लाइफ ऑफ द फर्स्ट ऑर्डर रिएक्शन ऑलरेडी डन. ठीक है, चलो आगे बढ़ेंगे. विल कम डायरेक्टली टू द ग्राफ्स. ग्राफ्स इज वेरी इंपॉर्टेंट. ग्राफ्स, what are the graphs? First one is first rate versus concentration, that is CT. The rate versus CT. What is that rate versus CT? चलो जरा हेल्प तो करके दिखाओ मुझे. What is that? We all know that integrated rate law expression R equals to K A to the power 1. So what we can say? So if it is rate and it is what? AT. That is, or you can say CT. It will be, I hope you all can see that it is just a straight line. Not a big deal, easy one, right? Next. So it is what? Easy. Second one. Yes, we have seen that also. Okay. Acha, backside we have seen one thing, that T half ki value, it is this. Is it depending on concentration or not? No. So independent on the initial concentration, that is C naught. C naught के ऊपर ये independent है completely. So what we can say? As anyways I have told you that T half for any order of reaction is directly proportional to C naught to the power 1 minus n. When you put n equals to 1, 1 minus 1, 0. So it does not depend on C naught. Okay. चलो भाई आगे बढ़ेंगे. So here next graph is rate versus concentration done. Next is T half versus C naught. We all know that for first order reaction, T half is independent. So therefore it will be a straight line. T half versus C naught. It will be just a straight line. Not a big deal. Easy. Next. What else? What else we have seen? All these things are done. Okay. And third one, you can say concentration, that is, or you can say CT versus time. CT versus time. CT versus time, how do you say that? Because we have seen that ln of, you can say KT equals to ln C naught by CT. So can we say ln is nothing but log base E, and I have told you how to convert this base or logarithm to anti-logarithm. E to the power KT equals to C naught by CT. So what we can say? CT by C naught equals to E to the power minus of KT. What we can say? CT equals to E C naught into E to the power minus of KT. So it is exponential kind of graph. What is this? It is a exponential graph. So how this exponential graph goes like? Consider it as CT, consider it as T. It will be decreasing. It will be decreasing with time. Yes or no? So how it will be decreasing? Because E to the power minus negative sign is there, right? So how it will be decreasing? It will be decreasing something like this. Okay, it will be starting from C naught. Any doubt? But they ask you some other thing. Say they sometimes ask you ln of CT versus time. So how do you say ln of CT versus time? You can say that KT equals to ln C naught minus ln CT. How it is coming? C naught minus CT, because we know that log of A by B equals to log A minus log B. What we can say? So it is what? It is something like t. Sorry. Send this k this side by k by k. Okay. Okay. Now, how can we say that this is what? This is consider. Acha, make it ln of ct. Ln of ct equals to, send this side, ln of c naught minus of t. Acha, minus of kt. Better we just keep it as kt only. kt. No issues. So what is this? This is what? Y. And what is that? T is x. Y equals to mx plus c. Yes or no? Chalo, zara dhyan se dekho. Here m is negative or positive? Negative. Means decreasing or increasing? Decreasing. Now c naught, whatever is the intercept, it is ln c naught. Decreasing. Slope comes out to be minus of k. Any doubt? No doubt. I hope you can do that very easily. And it is what? ln ct. And it is what? Time t. चलो आगे बढ़ेंगे to the questions. For the reaction N2O5 to NO2 plus O2, rate on rate constants are these and this. Okay. Then concentration of N2O5, not a big deal, very easy. First order reaction दे दिया है. देखो अब तुम बोलोगे सर कहीं कुछ तो नहीं दिया है. अरे you can see that. We have already seen that कि what is the rate, units of rate constant. With the help of unit of rate constant we can say that which order reaction it is. Can you see that order? What is the unit? Unit equals to time inverse. If unit is time inverse, so it is order, first order reaction. Yes or no? Yes. Why so? Because we know that unit of k is equals to, k unit was molar power 1 minus n per time, because n 1 minus, because for first order reaction n equals to 1, 1 minus 1 is 0. Molar पे depend ही नहीं करेगा, it will only depend on time. I hope you can see that. So therefore it is what? First order reaction. First order reaction के लिए we know that how to write the rate law expression. R equals to k a to the power 1. हटाओ. अब तो बस सीधा तुम्हें value रखनी है. What is reactant? N2O5. Okay. What is the rate? Rate is given 1.02 into 10 to the power minus 4 equals to. What is the rate law? Rate constant. It is 3.4 into 10 to the power minus 5 into concentration of A. What it is asking for? What is the concentration of N2O5? So basically it is asking for concentration of N2O5. N2O5. Yes, because it is only the reactant. So what we can say? Send it this side. You will get some of the answer out of it. I think it is the 3. You can check it. 3 will be the answer. First order reaction के लिए there are some graphs given. I hope we have already covered it. Not a big deal. आगे बढ़ो. A first order reaction has specific reaction rate. Specific reaction rate means it is asking for telling about rate constant. Rate constant means K is how much? 10 to the power minus 2. How much time it will take for 20 gram to convert into reduce to 5 gram? Always remember, because for first order reaction T half is constant. So for becoming 20 to 10 take same time, 10 to 5 same time, 5 to 2.5 same time. So what we can say? 20 to 10, 10 to 5. How much time it will take? T half. How much time it will take? T half. Because T half for first order reaction is constant, because T half for first order reaction is a constant. So what we can say? How much of the T half it is using? 2 T halves. अच्छा, T half की value कितनी होती है? 2 times of 0.693 divided by K. Yes or no? K की value कितनी दे रखी है? 10 to the power minus 2. 10 to the power minus 2 means 69.3. So 2 into 69.3. So that will be somewhere around 138. Not a big deal. Easy. Next. If the rate constant for the first order reaction is K. Okay. If it is K and time T required for the completion of 99% of reaction. Okay. Rate constant is this much. Okay. So it is telling that time required for T 99%. I hope you remember I told you some relations. T 99% equals to 6.66 times of T half. Yes or no? Remember? हाँ भाई. So in such case what will happen? T 99% will be equals to 6.66, that is 20 by 3. T half equals to 0.693 divided by K. K to K. It is given. Okay. So T99 20 by 3. Can we have? Do we have any answers here coming? Yes, we can have 0.231. 2 3s are 2 2s are 4. Okay, 4 point something. Option C. Okay, not a big deal. Easy. Next, The rate constant for the first order reaction is this much. The time required to reduce 2 gram to 0.2 gram. Acha. You can see that there is no relationship, as you can see that. So use the integrated expression Kt equals to 2.303 log of C naught by Ct. What is that? It is given K is given. It is asking for time. Okay. 1 by, so K की value रख दो 4.606 into T equals to 2.303. अच्छा into 10 to the power minus 3 भी है इधर. Equals to into log of C naught by C naught. C naught is given how much? It is C naught initial, and it is what? C at time T. So it is 2 by 0.2. It is what? Cancel how many times? Log 10. Log 10 की value कितनी होती है? 1. So here what we can say? T equals to 2.303. 2303 divided by 4.606. Can we cancel it? Yes. How many times? I think it is 500 times. Option is option B. Not a big deal. बहुत easy है. Next, the given graph is representation of kinetics of a reaction y and x for zero order and first order reaction. Can you see that it is constant? For zero order reaction, what is constant? Rate is constant. While for first order, what is constant? The T half is constant. Okay, so let's see. For zero order reaction, y should be constant. Y means y should be rate. Y is not concentration. No, y is rate for zero order reaction. Yes, it is correct. And x is concentration. No problem, correct. First order reaction, y is T half. Yes, and x is concentration. Option B is the correct one. Yes, of course we know that. Yes. I think there are two answers are correct. Rate and x is time. Anyways, both of them, option B and D, both are correct. Because for zero order reaction, rate is constant, and for first order reaction, T half is constant. Okay, next. Half-life of the radioactive carbon 14 is this much. How many times it will take from 200 to 25? So 200 को बस directly just do it. Half time में T half में कितना हो गया? 100. T half में कितना हो गया? 50. How much it wants? 25. Half में कितना हो गया? 25. How much of T half is being used? 1, 2, 3. So how many? 3 T half. And T half की value कितनी होती है? I hope you have given 5760. So it is. I think it is B. No, sorry, C. Next, when initial concentration of a reactant is doubled in a reaction, its half-life period is not affected. The order of the reaction is, I think half-life is not affected in first order reaction. Everyone, you know that. Now, collision theory of the reaction, it says that for any reaction today, according to collision theory, rate of reaction depends upon the number of effective collision. The more the collision between the reactants will be taking place, the more the product will be formed, or more the rate of reaction will be there. Now, the number of effective collision depends on two factors. There are two factors. One is, what is that? That one is probability, that how better something is colliding. So basically it is nothing but effective collision. So energy of the colliding reactant molecule, that energy, minimum energy should be more than the threshold energy. And second thing should be that greater than the threshold energy. And second thing is chance of effective collision. Chance of effective collision means the effective collision. What is effective collision? Let's see here. Consider AA and BB are going to give you 2 moles of AB, but how they should collide with each other? They should collide head on. So first of all, they should have this much of energy that they can easily collide with each other. Okay, they should have energy more than or equal to threshold energy. Second thing, they should collide in such a manner that they give the product. So it is proper orientation. So proper orientation will give effective collision. If improper collision is there or orientation is there, ineffective collision will there. They will again get detached. Okay, so two things are there. What is activation energy? Activation energy is the minimum energy. Activation energy is the minimum energy to reach equal to EAT threshold. Let's say that any of the, or you can say minimum energy required to make any of the reactant molecules energy equal to threshold energy is the activation energy. Okay. Next, an increase in the concentration of the reactants of a reaction leads to change in. Always remember, if you increase the concentration of the reactants, heat of reaction, threshold energy, collision frequency. If more the reactants will be there, the more the frequency of the, of course, if the more reactants will be there, they will easily and they will fastly, they will collide with each other. Next, reaction profile and concept of activation complex. Always remember, once A and BB are going to collide, there is a, you can say activated complex, or you can say intermediate is formed. So this activated complex is highest energy. It is of highest energy. When any of the reaction reaches to it, when you get the, or when those molecules get the threshold energy. If they do not get the threshold energy, they will not reach to it this point. Once they reach there, then older bonds will be broken and newer bonds will be formed. So AB, 2 moles of AB will be formed, and this older bonds will be dissociating. So that is of highly unstable, highly unstable. This is highly unstable. They are also called activated complex. Okay, so their energy is maximum. Okay, their energy is maximum. They are not intermediate. Sorry, I just by mistake I told intermediates. No. Next, in a reaction, reactants to form activated complex at threshold energy. So let's say this is the reactant, and now it reaches to highest energy. So here it gets the threshold energy. It is what? ET. It is what? ET. How much of energy minimum it needs to reach to that point? EAF. EAF. EAF is means activation energy for forward direction reaction. Forward direction reaction. And it reaches to the product. Okay. Now we can see that it is E reactant and it is what? E product. Can we see E product is less, E reactant is more? When E product is, what is delta H? I hope you know that delta H equals to E product minus E reactant. E product is less, E product is more. Less minus more will be negative or positive? Negative. So delta H is negative, means exothermic. It is for exothermic reaction. Can you see? So therefore heat evolved in the reaction. So this is something reaction profile diagram for the exothermic reaction. Okay. ET. ET is energy of the product, energy of the reactant. Not a big deal. I hope you understand it. What are these things? Acha. This, if it tries to go in the back direction, so it will be how much of the energy it will be needing? EA backward. That is EAB. Okay. Now I hope you see that. One thing very important you have to understand. Please remember this formula. Delta H. Heat of reaction is equals to EA forward minus EA backward. Either it is exothermic reaction or endothermic reaction. हमेशा बहुत important formula है ये. Next, in a reaction to form, now see, it is what? It is endothermic reaction. Can you see that energy of the product is more, energy of the reactant is less. So therefore, energy is being absorbed. Energy being absorbed, then only the final energy will be more than the initial energy. So therefore, what is this? It is for the, again, same thing. Because delta H here is positive, so therefore it is endothermic reaction. Next, Arrhenius equation. What is Arrhenius equation? Arrhenius equation tells about that how K, that is rate constant, depends on EA, that is what? What is it? Activation energy and temperature. So it is what? K equals to A into E power minus EA by RT. इसको जरा log ले लो, तो you will get that log K equals to log A minus EA by RT. Minus of EA by RT. Minus also. Now, so when you solve it more, finally you get that log, what it is giving? Such a bad. No. So 2.303. Oh, cancel. Okay. Log K base 10. Log K base 10 equals to minus of EA by 2.303 RT plus log A base 10. This is the form that we get after taking log. Next, the slope of the graph plotted between K and K versus time T will be what? I think you can just do that, because K equals to A into E to the power minus EA by RT. Take natural log. Take natural log. So what it will become? ln K equals to ln A. Can we see that? Can we consider it as A? Can we consider the whole part to be B? A into B, log A into B will be equal to log A plus log B. So ln A plus log B. So ln of E to the power minus EA by RT, because base is E here also. So base, whenever base is same, ये आ जाता है यहाँ पे, ये plus है. So ln A minus of EA by RT, ln of K. So it will be this. What it is asking for? ln K versus 1 by T. Okay. So it is asking for ln K versus 1 by T. What is the slope? Slope is, because it is something looking like y equals to mx plus c. So what is m? M ki value minus of EA by R. Minus of EA by R. Option A is the correct option. Next, which of the following is correct? Which of the following is correct with the, I think you can do that. ln K equals to EA by, no, minus of EA by RT. Minus of EA by RT plus ln A. Not a big deal. Easy one, right? Next, for a reaction, activation energy EA equals to 0. The rate constant A 200 Kelvin is this much. The rate constant at 400 Kelvin will be equal to. Please remember, jab later on we can change that into ln of K2. Whatever Arrhenius equation equals to EA by R 1 by T1 minus 1 by T2. It is the, consider K2 is what? Rate constant at T1 temperature and K1 is rate constant at T2 temperature. Okay, now so it is what something we get that. Now if you put all these values here, you will get the answer. Please do that, you can get that, not a big deal. Now if you have to change into log base 10, log K2 by K1 base 10 is equals to EA by 2.303 comes here 1 by R, T1 by T1 minus 1 by T2. Not a big deal. Just put all these values, get the answer. Here just the solution is there. What is the activation energy for the reaction if its rate doubles when the temperature is raised from 20 to 25? Now always remember degree Celsius kabhi mat chhodna, convert into Kelvin. 293 Kelvin. It is 308 Kelvin. So again use the same formula, ln of K2 by K1. Just consider it is what T1 and it is what T2. EA by, put it is log 2.303 1 by T1 minus 1 by T2. Use this, get the answer. Not a big deal, kar sakte ho. Okay, now here what the R value will be put? R will be 8.303. 8.303 kya? Because it is in kilojoule, all the values are given in kilojoule into 10 to the power minus 3. So it will be kilojoule per mole per Kelvin. Not a big deal, put these values, get the answer. A reaction having equal energies of activation of forward and reverse reaction has, of course, I think you remember delta H equals to EA forward minus EA backward. If both of them are equal, then X minus X will be equal to 0. So delta H will be equal to 0. Easy. Next, effect of catalyst on the reaction. Now always remember, catalyst does not affect delta H, but affects EA, that is activation energy. How does it do? Please remember what we can say, K in the catalyzed reaction. For catalyzed reaction, K will be more than uncatalyzed reaction. K catalyzed is more than K uncatalyzed if catalysis is positive catalyst is used. If positive catalyst is used. But how the reaction can be written or how the equation can be written from the Arrhenius equation I am using. K catalyst equals to A e to the power minus of EA catalyst by RT, and K uncat will be equals to A e to the power EA uncatalyzed by RT. From here what we can say, take ln of K cat equals to ln of A minus of EA cat by RT. From here what we can say, ln of K uncat equals to ln of A minus of EA uncatalyzed means it is uncatalyzed divided by RT. What we can say, it is the equation 1, it is what equation 2. What do you do? Equation 2, whatever is the equation 1 is there, equation 1 minus equation 2. What you will get? ln of K catalyzed by ln of K uncatalyzed equals to, because minus, once you do minus na, so log A minus log B equals to log A by log B. Okay, so what will be happening? ln of K catalyzed by K uncatalyzed equals to ln A cancel, because negative of negative will be positive. So EA of uncatalyzed minus EA of catalyzed by RT. Please keep in mind, that is how it happens. How the graph will be working? Graph will be working something like, consider there is a reaction something like that. So there is a reactant going to product. It is what? Product. It is what? Reactant. So consider it is without catalyst. So if you put the catalyst, what will happen? This reactant product is not going to change. So therefore what we can say, delta H is going to be same. But what is changing? When you are, it is the E threshold in the catalyzed form, while it is uncatalyzed form. When it is uncatalyzed, then E threshold will be high. So what happens? They just decrease the cutoff for an exam. Consider for an exam the cutoff is 600. If it makes it to 500, so basically the more number of students will be qualified for the reaction. Same thing catalyst does. Okay. Now the addition of the catalyst during a chemical reaction alters which of the following quantities? Entropy? No. Internal energy? No. Enthalpy? Does it? No. Activation energy? Yes. Next, in a presence of catalyst, the heat evolved or absorbed during the reaction increases, decreases, remains unchanged? No, because catalyst does not change delta H. So neither it will be negative or positive. Whatever is there, it will always be like that. So that was all from my side. So all the students, I would suggest whatever the question we have solved today, again go through that and solve all the PYQs as well as all the relevant question with that you have already done with that. Whatever I have told you extra to do, please go through NCERT for seeing all the examples. There are few things that I could give even more, but of course due to the time constraint we cannot do that. So from here I would suggest whatever at least the important type of question we have done, please go through them, and all the best for the preparation.